Hello, everyone, and welcome to part two of our Building with AI product series. Today, we're going to actually look at Hugging Face. Hugging Face is literally everywhere. You can't escape it if you want to build anything with AI and ML. And today, we actually are going to have someone from Hugging Face guide us through, Merve, on how we actually can start building with Hugging Face, what are the capabilities, and she's going to walk us through a demo of what she's built with it. So stay tuned after this amazing introduction. That song and music get me going every time I want to do something on this. So, hi, Merve, how are you?
I'm fine, thank you. How are you?
Yeah, good, good. So, before we get into things, I'm really curious where everyone is joining from here on the stream. Thank you. You could be anywhere on the internet right now, but you have joined us. So, really nice to you to do that. So, I would love to know where you're from, and have you actually used Hugging Face in some capacity? Hugging Face is doing so much to so many things out there. So if you ever use Hugging Face in any capacity, let us know where you're coming from. But Merve, since I assume you've used Hugging Face before, right?
Yeah, I mean, obviously. In my previous job, I was actually using it a lot, and that's how I get to know them and started contributing. And after joining their community events to contribute to their libraries, they were like, oh, you are actually quite helpful to other people as well, which is something we really like in our culture, to have like kind ambition and helping other people. And I was like, I really liked that, like the contributors were very welcoming to contribute to the libraries, and they were very helpful. And I was like, I want to be that person. And
Nice.
I want to do this for a living. So that's how I started working at Hugging Face.
Gotcha. And the caring, is that where Hugging Face gets its name? What's the backstory behind that? I'm always curious.
So what happened was that they were wondering if they could actually get an emoji in the Nasdaq, where there's often stuff like MSFT, like a very short acronym.
Yeah.
And they were thinking, like, if we actually offer this company, would they put an emoji instead of an acronym? So they just wanted to test it, and it unfortunately wasn't the case.
Okay.
But then it ended up like this. So
That's hilarious. That's I knew it was probably a fun backstory. You know, name your company Hugging Face, and be very serious about it. Cool. And to helping people, you built an amazing project around the tragedy and earthquake situation of the crisis in Turkey and Syria. Why don't you just, if you can give us a brief of how you're sort of saving the world with Hugging Face, essentially.
yeah, of course, thank you. It was, so basically, let me just write the link to it in the here in the chat so you can share it. So it's a map. It's like a heat map of disaster areas, and where people make like calls for help to and say what they need, like blank, if they need a shelter, if they need food and stuff. And we built like two models behind it. One was an intent classification model that says, hey, I need a shelter, and then it maps to shelter. And then the other one was a named entity recognition model that parsed addresses, and both of them use transformers in the background. And it channels them into this heat map, and then from this heat map, you can actually filter the needs. Like you can filter for shelter, and then help people out if you can, or like if people need to, because like the need arose because like the area that the disasters hit was like so big, to a point where it was nearly impossible to control everything for NGOs and government, at least for the couple of first days, because the earthquakes kept on happening, the aftershocks and stuff. And because of this, we were like, there's a lot of data. People are posting on Twitter that they need something, and they post their addresses as well. So we could actually get that massive data and make something meaningful out of it so that it's more controllable. And it was completely like a voluntary project, that there was like so many volunteers behind it, not only me, but I was the tech lead for the machine learning side. So I think Corey dropped. Hey. And today we are going to see sentiment analysis, which is the type of text classification. And it is roughly the same task that we are solving with the intent classification model that I have just talked about. So
hello, I am back. I'm back. And okay, so that was a catastrophe. I have some video problems, but you won't be seeing too much of me, which is probably a good thing. But
I would love
let's see. Yeah, let's see who's joining us here. Everything is sort of crashing now. So Abjit from India, don't have any idea about Hugging Face, so you've come to the right place. I think hopefully by the end of this you will have an understanding. Rashad from the West Coast. I'm not really sure what part of the West Coast, Rashan, but West Coast somewhere. And you've never really used it as well. That's so also great to know that we got some beginners. We've got Diane from Madrid, Spain. Never used Hugging Face. Love that. Also from my hometown or home city, Whale from Stockholm. Never used it before as well. So exciting. Got a good group of beginners trying to learn and understand how to use Hugging Face. So we were going to share a lot of different resources through this workshop. I'm going to go ahead and post, if my computer doesn't catch on fire, the links of all of these things here. Boom. So I know this is kind of stressful sometimes. We see a lot of resources coming. So I've put all of the links that Mary will share all in this one place, and you can find her. If somehow you're not following her on LinkedIn or Twitter, you can find her profiles all there as well. Cool. So without further ado, as my computer starts to crash, I'm just going to put some other posts. But Merve, take it away. Take us through Hugging Face and what we can do with it.
Sure. Let me, can you put my slide in here? Yep. So welcome again. Today we are going to talk about transfer learning using transformers. And about me, I work at Hugging Face, and prior to that, I was a machine learning engineer. I was building chatbots, text classification, and text retrieval applications, where you would have like a big amount of documents and you would get the information that you needed from them. And I was also, prior to that, was a data scientist working in both natural language processing and tabular data. And I'm also doing my master's at this point on natural language processing. And today, some of the emojis are not exported. This is my fault, I'm sorry. We will talk about Hugging Face, what is Hugging Face and what we do, transformers, and some tasks that you can accomplish with Hugging Face. So if you have no idea about machine learning, essentially, what machine learning is that you have a picture. For instance, you have two dogs sitting on the grass with flowers. You have the caption of it, and then you are trying to come up with a mathematical representation that learns the relationship between them, so that next time you input a photograph, it captions that photograph or image. And in here, like, again, like you want to find the thing between them. So what's going on is that each image is actually a RGB image with pixel values. So how they are represented is you have a matrix of these pixel values in red, green, and blue. And you have the text. And this text, how it's represented is that you divide this text into pieces, and then you map them into some numbers. And this is called tokenization. You turn them into tokens, and then you map them to some numbers. And you want to find a relationship where it maps the dog itself and its pixel values to the token, the token dog, and you want to come up with a representation in between them. And this is how computers see this data. And do you have any question, Corey? Okay.
No, just a dumb comment. I always like that there's
Okay. I love that.
the cute dog photo is like what gets people into the machine learning side of things. But I just want to say, yeah, still a lot of people joining haven't used
Right.
Hugging Face, so this is great. This is going to be a good intro into everything they do.
And should I continue? Okay. What we do is to learn this stuff is that we train something called neural network. And this neural network is essentially extracting the relationship between these two. And in it has like multiple layers. And in the first layer of this neural network, you have very shallow features extracted from images or text. For instance, at the first layer, you have edge detection, corner detection, like very, very shallow things. And in the latest layers, you have dog-specific features. And at the state of art, what we do is, and also the same goes for text, where you have, in the first layers, you have grammatical information. For instance, if you are training on English language, you have grammatical information, you have like syntactic information, you have very general rules stored in the English language. And at the latest ones, for instance, if you are training on legal text, you have legal specific jargon. And at the state of the art, what we do is we have, since at the first layers we already have this information, we do not really bother ourselves to train a model from scratch, because what you do not want is you have like limited amount of data, you have limited amount of GPU hours, and you wouldn't like to waste them. So what you do instead is cut the first layers, actually get rid of the last layer that has very specific information about the training data, and get the first layers and use the information that is learned in the first layers in your own use case. And this is called transfer learning. And transfer learning is when we transfer the information that is learned in the previous models to our own model. And you know what? This actually requires less amount of data, and your model performs better if you choose to do this. This whole thing where we get rid of last layer and put a layer on top of it and training again is called fine-tuning. And for instance, we have like various tasks we can accomplish with this, but today I will specifically go through natural language processing. But what are transformers? Transformers is the architecture that we do to accomplish use to accomplish this fine-tuning task. And what makes transformers powerful, I would say, first is transfer learning and fine-tuning. And secondly, there is something we call self-supervised learning, which I will explain, or let me explain. So for instance, in every training, you require labeled data, and labeled data in here means you have the sentence, I am very happy, and then you have the label of the sentiment of it that is positive. This is a positive thing that I am happy. But the base models that we use, the one that you can see here, like the first 3 layers, are trained without the labels. And how we do it is that, for instance, the most popular example is GPT-like models. And how GPT is trained is like you have the paragraph, for instance, and then you cut the paragraph somewhere, and you have like the beginning of the sentence, for instance, and you try to predict the rest of the sentence by the previous sentence. This doesn't require any labeling. You can just do this by scraping all of the Wikipedia and passing it to GPT-2, or like the architecture, and then just have your base model. The same goes for BERT as well. BERT is trained with something called mask language modeling. And what you do is, in a given paragraph, you mask the 15% of the words, and then you try to predict those 15% masked words, so that your model learns the relationship between the masked, between the words and the sentences as well. Like, this is called masked language modeling. Do you have a question?
I have a question.
Yeah.
No one in the audience has asked a question yet, so go ahead. But my question is, you talked about like giving the 15% or representing the language. How does the model understand that, or how does it break down the sentences so that it can know as to what to make the prediction on, basically?
It's being done randomly, like how you so you cut the I have said words here, but like essentially you tokenize them, and then you remove some of the tokens and write a mask token. Like, there is a token called a mask, and then you put that token and you ask model to predict that mask. And this is like a training objective of the model. So this way it learns the distribution of the language. For instance, it learns, I wanted to show you something, but maybe later on.
Ooh,
for instance, no, but like, for instance, it learns the relationship between the word king and the queen. Or like it learns the relationship between Istanbul and Turkey, because these words are passing together so often. It is very likely that after you say Istanbul, you will say the word Turkey. So it's this way, like it learns the relationship, like it learns that there is a relationship between those words. And this is how it sort of comes up with the semantic representations, like what king is and what queen is, sort of. And this is like distribution of the language, essentially. Very nice. I hope it's clear.
No, that was. I wanted to get you to start talking about tokens a bit, because I think that's where some people get the questions from. And sure enough, all part of my master plan, we do have a question around tokens. So is there a standard limit of tokens a model can take from Divine? Love the name.
Like, you can, I don't know, like you can just train models with as much tokens as you want to. Like, I don't think so.
Is there like a benefit or for using less tokens?
The more tokens the model sees, the more it can generalize. And it means the more data, like essentially your tokens are your data. So yeah.
Nice. More tokens. Gather all the tokens. Great.
Okay, let's continue. And this whole mask language modeling and this just close the right-hand side of the sentence and predict that is called self-supervised learning, because you do not have any labels like supervised learning. The model is supervising itself. And then you have something called attention mechanism, which I will not go through today, but it's essentially it essentially controls what models should pay attention to. You can learn the deep dive, you can do the deep dive on it. And since this is a Microsoft workshop, I wanted to give 2 examples of these transformers. One is Codex and Copilot. it's used for text generation, and it's based on GPT-like model. As far as I know, it's actually GPT-3 fine-tuned. And then you have ChatGPT, which is one of the most famous ones, and it's based on GPT-3. And yeah.
Well, I was gonna say this workshop proudly sponsored by Microsoft. Thank you for that. Shout out.
Shout out to Microsoft.
Yeah. We do have a question. So I suppose one needs to know computer vision for designing first layer of images. So I think he's talking about like the earlier example with the cute dogs.
Yeah.
How do you design the first layer for a text-based model? If that makes sense.
In this workshop, I will not go through that, but I would say for text models, like it depends on what type of architecture you want to use. Like if you are using, for instance, transformers, you will not have to design anything. You just pull the BERT model and put a classifier layer on top of it and just train. But if you want to use something else like RNNs, like you need to find the best model that can represent understand the representations very well. For instance, for text, it's sequential data, which means you need layers that understand the sequences. And for images, it's often 3x3 convolution kernels. So you need to use something like a convolutional neural network, or like we have also transformers models like VIT or DIT and others to use, because like at the end of the day, it just depends on the shape of your data. Like if that makes sense. Like for audio as well, it's like a sequential model, like it goes through time, and you also have like sequential stuff for time series as well. So yeah. But in what I'm talking about today, you don't have to bother yourself with this stuff, and that's why it's very good.
No stress, Kati.
Yeah.
Got you. And then Mati had made a point. The mask model is similar to the skipgram model, I think.
Yeah. Like it's a bit like, like at the end of the day, what you want to do with Word2Vec or like Glove or like the basic examples, you want to come up with the distribution of the language. Like every language consists of word or token distribution. Like you say the word hello a lot, which means it's probably somewhere in common place in your distribution. So something like this.
Nice.
Let's say.
So yeah, great questions, everyone. I asked if anyone's using Copilot here. No one answered me, but I was trying to prod to see if we get some customer feedback on the stream. But cool. This is a big question. I'll wait till the end for this other question. Niha, they asked about avoiding bias in models, but we'll get through it, and then maybe we'll save that one for later.
Yeah, let's go. And as you can see here, you have the BERT model in here, and what you do is at top of it you put a classification layer that classifies stuff. Like for instance, for question answering, if you want to do question answering, where you give a question and a paragraph that we look for the answer for the question of, and you want to extract answer from a given text, what you want is you want to predict the start and the end span of that answer, like saying, hey, around the answer of this question starts at the 29th character of this paragraph and then ends in 56th character of this paragraph, and then there you have your answer. For text classification, it's just a simple classification layer that you put on, that you would normally put in the when you are solving text classification. And this is what we do at the state of the art. And then we have we don't only have these for NLP, but we have like many models that aid at least like that are backed by transformers. Like for instance, the latent diffusion and DALL-E used a model called CLIP in the background that consists of transformer. And then you have for computer vision, you have data efficient image transformers, mask former, you have vision transformer. For audio, you have wave to vec, step former. For multimodal, like this one, which is text to image, you have clip, and so on. For natural language processing, you have BERT and GPT and T5 and more. Yeah.
I have a question, since we have a lot of beginners here and they might
Yeah.
see all these models. How do you just suggest like a beginner approach these models? Like, should they try to use all of them? I mean, obviously with their use case, like if I want to do NLP, should I try BERT, see how well it performs, maybe then go to GPT? How do you sort of approach that?
So when I approach a model, what I often do is I try to find the pre-trained model for my own use case. Like, for instance, what we did with the disaster response project was that we went to HuggingFace Hub. We have taken the BERT checkpoints that are trained on Turkish language, and we have trained it our own data. So what you do is you experiment around these models. Like, there is like variations of these models as well. You have BERT, you have Distilbert, you have Roberta, and so on. Like, these are variations of BERT models. You try them on your own use case and see which one works the most, and you just put that in the production, I would say.
Nice. And just a small update, we do have people using Copilot. So
nice.
Yeah, that wasn't left hanging. I had to push to get those answers. But thank you, Bruce, Diana, Rashawn as well. Copilot users love it. Love to see it.
And I see a question. It says, is it possible to train a model on a book text and expect the model to answer questions, or do we need to convert data from questions and answers? So there is two types of question answering problems. One is context-based and one is closed book. And context-based is during, like, you have trained your model to answer questions generically. Like, you have small paragraphs and the answers. Your model has the ability to answer the question from a given, like, during the inference time, you give the paragraph and you give the question, you get the answer from that paragraph. And this is called context-based. And what closed book is that you can actually train a model on a book and get the, like, you don't give any context, but you ask questions and you get the answers yourself. So I hope this answers the question. And how can you use them? There is like so many use cases for these models. It's crazy. You can make a bot that answers questions from PDFs using document question answering models. Like, you have PDFs and you want to ask questions to these PDFs to retrieve information. You can do that. You can transcribe speech to text using automatic speech recognition models, which are used in assistants like Alexa or Cortana, let's say, or Siri. And then you have you can create a conversational agent that speaks just like your favorite movie character. It can write code, or you can do creative writing using conversational models. You can generate realistic images using text-to-image models. And what we do is we use transformers library to train these models, or like fine-tune these models, and these transformers works on all modalities, as I just said. And that's why we have something called HuggingFace Hub. This is where the models, like the base models that we fine-tune on, exist. So what you do is you go to HuggingFace Hub, and these are all open source. We are an open source first company. So you take the BERT model, and then you put your classification layer on top, and then you fine-tune on it with your own data. That's why we host these models, firstly, so that you can use them using Transformers library. And then we also host data sets, and we have a Python library for data sets, because like sometimes you just don't have your data set and you want to train a model that answers questions. You can take the question answering data set from HuggingFace Hub and train train your model on that case. So we have a lot of data sets, and yeah, you can also host them yourself.
I have a question
Yeah.
for all the new people. But so you said, using Hugging Face Hub, that's where the models live. If I want to fine tune the model and I, do some training on that, is that on Hugging Face? That it happen on Hugging Face, or do I need to use any other resources or tools for that to happen?
So you take the model and if you need a data set, you take the model and the data set from Hugging Face, and then you pull it on your local machine, and then you use Transformers library itself to fine tune the model, or like train a model. And then, yeah, like you have the Python libraries, you have the models on the Hugging Face Hub, you have the data sets on the Hugging Face Hub, and many other stuff over there.
Very nice.
And I want to, since I have just said it, I want to elaborate on something. So all of these tasks, and there is nowadays even more tasks on Hugging Face Hub, you can actually use models out of the box instead of training your own data. Like what we often do is we do not even fine-tune our own model, but we find a model that fits our own use case on Hugging Face, and then we pull that model and we use it for our use case and see if it works. If it doesn't work, you do fine-tuning. And to use these models, on Transformers, we have developed a lot of good abstractions called pipelines. And what you do is you can just use them with few lines of code, and I'm going to show you. So essentially, a pipeline is, think of it as a box, and it contains the preprocessor of the model itself, and the post-processor of the model. So when you input I love this movie to the pipeline, you get the probability of the label and the label itself, which is positive. You have like 99%, with 99% probability you have positive. And this is what makes it powerful, I would say, because you don't even require any information on machine learning. You just need to call the pipeline, and I'm going to show you how. So for question answering pipeline, for instance, you say, what is the purpose of this quest? And then you have this text that is coming from a fantasy book, and you get the answer span at the end. And the workflow, if you do not want to train any model, is you pick a model from the hub, you pick a pipeline that suits your use case, and you're good to go.
Cool. We had some questions around pipelines.
Okay.
So Lone Never Infinity. I love trying to guess what people's usernames are. This is what I do when I do. I'm working on a text summarization app. Is there any pipeline for that, or should I create myself? So maybe answer that, and maybe also talk about how can you create your own pipeline. I'm not sure.
Great. There is actually a pipeline. I want to share my baby, if it's okay. So
no, yeah, sure. I mean, why would I stop anyone from sharing their so proud babies?
This was my first project. I posted it in the comments,
okay.
Not comments, but the other
the chat
tab. Yeah. And this project is my first project ever. And I have actually built it for software developers who would like to use machine learning models out of the box in their own applications. And I have divided things into tasks because I really feel like the software developers want sort of like an abstraction over what they want to do. For instance, this is a great question. I'm working on a text summarization app. You just go to Hugging Face tasks, and just go through the text summarization, and you have all of the information that you need. And for instance, there is two types of text summarization. One is extractive text summarization. And how it works is that you have a big text, and you have a, you pass it, and then it extracts the important sentences that it thinks it's important actually, and then it concatenates together and gives you the thing. And then you have abstractive text summarization, which is when the model actually starts making up stuff. Like it sometimes doesn't do that, but it doesn't extract the important stuff, like important sentences. But what it does is that in a conversational manner, like how ChatGPT does, it summarizes you things, but in the way it can make up things. So you need to pick which one suits your use case the best. And I would say the extractive summarization works more efficiently and takes less time to train. One is an understanding model, and the other one is a generative model, like GPTs, sort of.
Nice. That's awesome. And you made this while you were at HuggingFace or before you joined HuggingFace?
After I joined the HuggingFace, because before that I always worked with software developers that were willing to build their own things and put machine learning itself
inside it.
Yeah, and like you just don't need to train a model from scratch. You can just go to HuggingFace app, pick something, and put it in your product, and voila.
Very nice. So one other question from Kathy. Thank you for all the questions, Kathy. So could you please touch on how to fine tune, for example, which cloud service to use and expected cost? So of course the answer is Azure. Of course the answer is Azure.
Azure.
That's all the answer that we're going to accept here. But
Yeah.
you can go through how that process actually looks as well.
Yeah, I'm gonna go through the fine tuning itself, but like I would say on a GPU, it takes like 3 minutes to fine tune a birth checkpoint, and it's pretty amazing in my opinion. It just depends on like which cloud service you want to use. But like for instance, I'm going to go through Azure today, and like we have like an integration with Azure where you pick a model. For instance, this is for serving the model, not training the model, but you can pick a model from the HuggingFace hub, and you can just deploy an application using Azure in like 5 minutes, and it opens an endpoint for you, and you just do inference. Let's continue. And how to use pipeline on Python is that you do from transformers import pipeline. If you want to do question answering from a context, you have your context and you have your question. And then you initialize your pipeline with the name of the task. If you want to use another model, so by default, it comes with a model out of the box. But if you want to use another model, you can also pass the model checkpoint that you have found on HuggingFace Hub. You initialize your pipeline and then do inference by passing question and the context. And then you have the answer with the probability. You have, it's like a dictionary, and then you have the answer part of it. And for text generation, you have the text input. For instance, this is how GPT-like models actually work. And you initialize the pipeline text generation, and out of the box, this comes with GPT-2 model. And you just pass your own text input to this pipeline, and then it completes your text and returns the completed text. And today I'm going to go through these code snippets that are looking very small and very complicated, but I just wanted to elaborate on what you can do with Transformers library. So for NLP, at least you can train a language model from scratch, like BERT or GPT-2 or whatever you want, using Transformers library. So Transformers and the trainer class itself is sort of like this very easy to use abstraction over this PyTorch, like what you would normally do to train from scratch in PyTorch. It's like, it's very convenient. You pass your model, you pass your arguments, you pass your data set, and it trains for you, and that's it. It makes it very easy. And you can also fine tune on text classification, which is what we are going to do today. You can fine tune for image classification using, so basically in here we have used BERT. But you can also fine tune on image classification. For instance, you have Microsoft's, again, Swin tiny patch model that is a base model for images that you can use. And then you train your model on it using trainer, and voila, for instance, you have like a image classification model that predicts what animal it is. And lastly, before going to the notebook itself, we have an integration with Azure, like an application on Marketplace, where you can pick any model from HuggingFace Hub. You'll first launch a managed application on HuggingFace, on Azure Marketplace, and then in that application deploy an instance, and it will just open an endpoint you can send a request to with your inputs, and you can get the output directly. And if you would like to learn more, Corey already posted a link, but you can just reach out to me on marve@huggingface.co. And for now, we can have some questions, but we will have a notebook as well. So if there's any questions, we can have it. And this is our Discord. Let's see. Can a single project use two pipelines? Of course, you can just add them together. Like that's what most of the projects these days do, actually. Like because these libraries make it so easy to use these models, people have started to develop very cool projects. For instance, let me think. I had a project where I had a text generation model from English language, I think. And then I had the English to French, French to English, and then English to French translation models. And I added them up. So like a French input comes, it is translated to English. And then I put this English input to the story generator, and then I get the output of that story generator, and then I pass it to the English to French translator, and voila, I have a French story generation model. Like not model, but it's like a pipeline. So you can just combine them like Lego bricks. Have there been any work to make this model smaller by quantization, etc.? If yes, can they run on edge devices? Yes. There is many of them, and like there is tools that you can use, like OpenVino, for instance, is one of them. If you want, you can, you can like optimize over the precision to make them smaller, and you can also prune your models, as in like you try to predict which information is less important, and when you are making predictions, and you get rid of them. Yeah. Are there any models, pipelines, which work directly on speech without intermediary conversion to text? You would lose emotions. Imagine commentator shouting goal. They said, could you go back one slide? Yeah, it's here. Yeah, Corey's computer has died, apparently. RIP. So good question. My expertise is not in speech without intermediary conversion. Like, how are you? Like, you want to? I guess. Yeah, like you probably do have. Like, you probably have speech like classification texts models without necessarily translating them into text. I would say that, yeah, maybe it's just predicts from how the signals are going up, so that a person is excited or whatever. I think it's possible. Do you have any other questions? And if not, let's go to the notebook. I would like to go to the notebook, but Corey is not here. Let's see. Code spaces. I wanted to share my screen. Can you cannot see my screen. I need to wait for Corey. Okay, can models be fine-tuned by cloning locally? Yeah, that's what you're actually doing. Like on HuggingFace, you have your models repositories open source, and what you do is you clone those repositories and you use the transformers library itself and your own data set, and you just do all of the fine-tuning process on your local machine, and not it doesn't take place in HuggingFace Hub really. We do have one company project called AutoTrain. If you want to, you just drag and drop your data set and pick what you want to train on, and it just trains for you. But we are like, we provide all of the tools for you to fine tune on your local anyway. You have the open source models, you have the open source data sets, you have the libraries that contain these abstractions, and that's it. Like, yeah, my answer would be yeah. We are going to see how to do that.
Oh God, I was really worried I missed all the magic. Thank you. My charger was fake charging my entire laptop. It was like the light was on, and it just completely died. But yes, I'm not going to miss the demo. Okay, great. Let's see it. Oh, there's one more question. Haven't seen any limitations on text size at first sight. Can I apply on larger text?
Yeah, you have. So basically, each model has this context window that it works the best on. And you have big models, like models that handle the long text, like long former is one of them. Or you have long T5, you have long T5, and you can apply on larger text. Yeah, I think there is also something called Big Bird, because like, you know, there is like Sesame Street characters.
Yeah, yeah, of course.
Big Bird is one of them. And funny thing is, in every language, Big Bird, the character is translated in like in a different way. For instance, in Turkish, it's mini kuş, which is small bird.
Oh, wow.
It's almost sarcastic.
Yeah. That's interesting. There's another question there. I like these app ideas. Keep them coming. It seems like everyone wants to start building.
There's so many software as a service.
Yeah. Create an app to synthesize text and find commonalities or different viewpoints. Any recommendations on how we can do models to use for that?
What I didn't understand. What is the commonalities of different viewpoints really in this context?
I think it's like maybe like embeddings or like trying to find relationships. Like maybe you know how people do like customer feedback or something like that, and like their opinions, and seeing okay, how are they similar? Maybe some text similarity. That's me assuming, but Rashaan, let me know if I completely got that wrong.
Yeah, there is like multiple ways of doing it. One of them is topic modeling, and you don't even need like a pre-trained model for this. But if you want to use it's like similarity, like meaning similarity, what we call like semantic similarity, there is some task in Tasks website, TM, called sentence similarity that you can use. And I used it previously in my jobs a lot. Like you can just use it to extract text, you can answer questions, you can find similar documents and stuff.
Nice. I think assuming is Turkish in the chat. I'm always afraid to put. Is a nice thing to say? I don't know. I'm always afraid.
Yeah. They said very beautiful.
Ah, okay. Now we can put it on there. Needed that approval before.
Cosine similarity works well for text. I would say it doesn't work as good as the BERT models that are trained on sentence similarity. Like it's called SBERT, and they work better to my observation.
Nice. Good tip. Pro tips. This is what we're here for.
You can, if you could share here. I'm going to scroll down now. Can you see?
I think you need to zoom in. You might want to zoom in. It's still kind of.
Yeah,
Oh, wow. I like that. Now we're in there.
Okay. I'm going to make the fonts larger. Okay, so today we are going to use code spaces. So I have the repository, and we are going to go how you can do it. You can click use this template and say open in code space, and share this tab instead. Can you see my tab again? It says setting up your code space. And it's going to set up a code space that you can use for machine learning. And I have notebooks here, and I'm going to use sentiment analysis notebook. If everything is okay, so it's installing the requirements and stuff, but in here I didn't add the transformers as a requirement, so we are going to install it ourselves. So let's wait a little. But today what we are going to do is we are going to use the glue benchmark, which I'm going to show you. Glue benchmark. Share this tab. So let me go back. Glue tasks. So glue benchmark, what it is that it is the benchmark that is used for text classification. And what we mean benchmark is this. So when you go to papers with code, you will see many data sets and papers and other stuff. And let's say, for instance, sentiment analysis. Okay, so let me explain. To compare our models in these tasks, for instance, sentiment analysis or sentence similarity, we have several data sets, okay? And we have these splits of these data sets. We have the training split, which is used to train your model. We have the validation split, which we use to validate at the end of every epoch, so that our model corrects itself and controls itself and stuff, or like every 5 epochs or whatever. And then we have our test split, which is used to test the model for real, like after the model is trained. And this test split is often used to compare different models that is trained and validated on the same data set. And this is called benchmarking. Like we have benchmarks on texts. For instance, for sentiment analysis, we have Stanford's sentiment tree bank data set. And these models are trained and validated and tested on Stanford Sentiment Tree Bank, and you have the leaderboard of this task. So if I could find benchmarks anyway. So Stanford Sentiment Tree Bank. For instance, you have the models, various models that is trained on this task, and you have the leaderboard, and currently T5 with 11 billion tokens, I would say maybe is the state of the art in this task. Everyone is like sort of uploading their models result and reporting it so that you know which one performs the best. And today we are going to fine-tune our own model for Stanford Sentiment Tree Bank. There is multiple benchmarks. For instance, this is used for like you input a text and then you see if it's grammatical correct or not. And then you have Microsoft Research Paraphrase Corpus, MRPC, which is used when you have like 2 texts and you try to predict if one is the paraphrased version of the other. And you have Cora question pairs, which is predicting if one question is meaning the same question, same thing with another question, and so on. Like we have multiple texts, multiple benchmarks like these when it comes to modeling text understanding. And this is the benchmark. And let's share this tab. So today we are going to do this. Let's, I think it works well now, yeah. And we need to pick a Jupyter kernel or Python environment, yeah, Python environment, to start running our notebook. So we first need to install transformers and datasets libraries so that we can do the fine-tuning. We will use the datasets library to load glue benchmark and then load the Stanford sentiment tree bank dataset from that benchmark. Then we will use transformers library to call one of the BERT models on HuggingFace Hub. So what we do is share this tab instead. You go to models, and then you want to pick one of the base models. For instance, for natural language processing, you want to pick FillMask, where you can find the BERT checkpoints. For instance, you can use BERT-based uncased. You can also filter for languages as well. You have many languages, but we will use for English, and these are trained for English. Let's see what we are going to use today. Share this tab instead. And another thing is, at the end of the day, we are going to push our model, like we are going to fine-tune model, and we are going to host this model on HuggingFace Hub, so that later we can directly use Azure, we can use any inference service that we want. So for this, we need to authenticate ourselves, okay? And HuggingFace works with a token-based authentication. So we do HuggingFace CLI login. We could also do something like notebook login, but today we are not going to do that. So we need to go here and then share this tab instead. And then we will have like two tokens. One of them is for inference with read access, and the other one is for the one I use in notebooks with write access. And we will copy this. And then going back, we will paste it here. I love. And add it as a Git credential so that we can directly just push our model. And then we need to install GitLFS to host our model. Just a second, it's sudo. Yeah. And we are going to import transformers and check the transformers version, and then we will start fine-tuning. So as I have told you, we can just make this go back. So as I have told you, we will use a Stanford sentiment tree bank dataset under glue benchmark, and we could have done something else as well. We could use MRPC. Like, it depends on what problem that you want to solve. We could use semantic textual similarity, which is the task I have gone through today. For instance, you want to assess if two documents are similar, you use that. And we are going to use, again, the task is Stanford sentiment tree bank 2, and then we will use Distilbert base uncased model. Let's see how it looks like from HuggingFace Hub. Share this tab instead. This is like a smaller version of BERT so that it fits to many places, unlike the BERT itself. And you can predict the mask, as I have told you today. And share this tab instead again. We will first load our dataset. We will do from datasets, load metric. So every task comes with its own metric. For instance, for text classification, it's often the accuracy, like how accurate, or like F1 score if you want to use. It comes with accuracy already, so you can just directly load the accuracy metric. these data sets, these tasks specifically are coming with that. So what we do in here, we load accuracy. And then the data set itself is from Glue benchmark, we load SST2 sentiment tree bank data set. And we can see how our data set looks like. Is it still loading? It's essentially like how it looks is that you have the training, validation, and test splits, and you take the training splits, and then, interesting, I don't know why this runs a lot. Stop.
It's the classic curse of the demo. It never works on the system. Yeah, I'm coming out of nowhere. I'm here still.
No, I don't want to restart the kernel. Oh my god. Anyway.
Maybe you could just walk through the rest of the outputs and maybe.
Yeah, I can just do that. So you can run this if you want to on your local, but I have already ran it, so it's perfectly fine if I do that. So first element of the training set is the sentence and its label, which is negative, and the ID, like the 0th element. And then there is a small script that shows how the data set actually looks like in a pandas data frame, and you have too loud, negative. It's far tamer than advertised, negative. You have its electronic expression through cyber culture. I don't know how this is positive, but it's positive. It is as bad as you think and worse than you can imagine. This is negative. Like you have how the data set looks like. And then you can compute the metrics using like your task comes with a metric, as I said, and you can see how your metric looks like, which in this case is accuracy. And let's continue. So as I said, for text, we have a tokenization process, and we need to tokenize our data set before we pass it to the model itself. So what we do is Transformers has an auto-tokenizer class, and what auto-tokenizers does is that every model has its own tokenizer, and it's stored inside the model's repository. So auto-tokenizer automatically loads these the model's associated tokenizer for us, and use fast is to optimize, like it changes the backend and optimizes the tokenization process. So when you pass use fast, you should do that probably. And we loaded the tokenizer, and then when we pass 2 sentences, we see that we are returned with multiple numbers, which are, it tokenizes these texts into smaller chunks and then maps them to numbers and the digits. And then we write our pre-processing function. You pass the examples inside, and it returns the tokenized examples. And what it does is that it returns you with the tokenized result of the sentences. Like for instance, when we do pre-process function and we pass the first 5 examples of the data set, we are returned with these numbers for every single sentence. And it's a list of lists, with each inner list being the sentences tokens. And then we can use dataset.map. This is sort of like an it's like an abstraction that runs more optimally over the data set. You call dataset.map. You call your pre-process function. Dataset was the dataset that we have passed. You put the pre-processed function and you say batch true, and it does batch processing on the dataset, and it returns encoded dataset, which looks like this roughly, but all of your dataset, and it runs faster. That's why it's very cool. And the cool thing is these results are automatically cached in by the datasets library so that you do not have to run the same thing over and over again. So it's more optimal again. And going through the fine tuning, we need to load our model. And what we do is we have, just like auto tokenizer, we have auto model for sequence classification. So for every task, we have this abstraction over that task, and text classification is called auto model. Sequence classification. And what auto model does is that bring the base model to me and put the associated task layer on top of it, and just wrap it up in a model so that I can pass my inputs in. So you have the BERT model, and then you have the sequence classification layer on top of it, and you just use that and not directly the BERT model itself. Because BERT model just returns the mask, like what is given mask, the sentence, like a word, sorry. And then you pass number of labels that you would like to predict, because then AutoModel for sequence classification knows how many output nodes that it has to put for sequence classification. So in this case, we have positive and negative labels. So we pass number of labels to 2, essentially. And we import training arguments and trainer, which I will go through, but I hope this is understood. If not, I can go through again at the end of this workshop. And what training arguments does is that it is just set of the hyperparameters that you would like to pass to when you are fine-tuning your model. It's like the settings of your model when you want to train it, like number of epochs, number of batch size, the weight decay if you want to use weight decay, which metric you would like to use, and if at the end, if you want to have all of the models, or if you would like to load the best model. And then this push the hub parameter is going to let us automatically push model to the hub. And this is the output directory, and where we are going to also push the models, like the checkpoints. So at the end of the day, after I train my model, it will be automatically pushed to this repository in Hub, which I'm going to show you. I already trained the model, so we know how it looks like. And then we just write a simple compute metrics function. And this is like when you make a prediction, it returns the predictions and the labels. Predictions is like the probabilities. It returns what you have predicted, and then you pass it to metric that we have loaded above, which is accuracy. And you call the compute method of accuracy, and you pass your predictions and your true labels, essentially. And then we have to pass the validation key of the dataset. Validation key is essentially what I have just said. You have the dataset itself, and you have the training split and the validation split. And this validation key is how your validation dataset is called. It's not something fancy. You could just replace here. And to trainer, what you pass is your models, your training arguments, your training and validation data set, your tokenizer, the preprocessor, and your compute metrics function. And when I initialize the trainer from the arguments, it creates a repository on Hub, and then it clones it to my local. So I'm gonna show you at the end of the day, my model looks like this. So this is the final version, but essentially in the beginning, when I initialize the trainer, it creates a repository on HuggingFace Hub for me, and it clones that repository so that it can write that model inside that repository and later push that repository. And that's why in trainer, I have passed push to hub to true, and I passed my name of the repository. So let's go back. And we can just, after we initialize trainer, all we have to do is call the train, and that's it. Like, it just trains my model. It's like very, very easy to train a transformers model. You have, like, you can see the training loss, validation loss, and the accuracy in here as you train. And then at the end of the training, it will just push it to the hub automatically. And then trainer also has an evaluate method, and it's just according to the metric that you have passed, the metric function you have passed, it's going to create, it's going to evaluate your model. And then you can, again, like after you evaluated the model, you can push the evaluation results using trainer.pushToHub. Like at the end of this training, we have actually pushed our model to hub. But if you want to also send the result of it, you can call push to hub again. What is being pushed to hub is, firstly, the tokenizer of this model, so that you can use the model, that model repository out of the box. The model configuration of distilled word sentiment, the model itself, some tokenizer configuration, and something that we call a model card, which I'm going to show you. It's like an interface. So this is what is pushed to hub. And there's so many things that I like in this repository as a nerd, but this part is the model card. So I'm going to show you what a model card looks like. So it's essentially a README file, and it has this free text part that is automatically generated by the trainer.
I think you switched the tab.
Sorry. This is the, yeah, thank you for reminding me. So I'm going to show you a couple of things that I really like when I version the models on Hugging Face Hub. So you have the model card, and this model card has this free text template that is automatically generated by trainer. The loss and the accuracy or evaluation results is written there. You have your hyperparameters written here. You have your training results written here. And you have your framework versions that you have used. So this is like very good for reproducibility. Like next time when you are like versioning your models, because like at the end of the day, you run, as a data scientist, you run a lot of experiments, and you just need to pick the one that performs the best. And thus you need to version these with the necessary information. And it also has something we call metadata, which is just a YML. You have the license of the model, you have the data set it was trained on, which is again generated by trainer. You have the model index, the task that you are trying to solve, which I'm going to show you why these are used, but yeah. You have the metrics and how they perform on that metrics, okay? And when I go back to the model repository, I see a couple of things. One is this evaluation results. And this is possible, like this is put here, and this is also pushed to papers with code, the benchmark I have shown you. You have your results because trainer has automatically written these results to the model card, which is very cool, I think. And then you have the data set that is mapped because trainer has written it for you so that you know which data set your model was trained on. And you have the framework, and then you also have your training metrics prepared, and then you have like the TensorBoard instance that hosts your training metrics here, which is again automatically trained by just generated by trainer. I'm just going crazy over it. I think it's very underrated. And lastly, you have the inference API enabled, you can just send a request to this model if you want to, and like at the first days of the Afet Harita, like the disaster response project, we have actually used Inference API because it was hosting our model, and we did not have much resources, so it made a lot of sense. If you have a pro account, you will never get rate limited as well. If you don't, if you just stress the Inference API too much, you might get rate limited. But because firstly I have the model, I have the tokenizer, I have the task written into the model card, I can simply enable this Inference API. I can simply use it out of the box. It will load the model and make it work out of the box for me, and it will just return the training results.
Cool. We actually had some questions, and maybe we'll wrap up from
Yeah,
here.
I think like it's already done anyway. So
Yeah.
this was the last thing that I was.
One of the questions is around if they can work offline with HuggingFace. So install libraries, use them offline. And I think the earlier question was actually using the models. But is there any offline capability with HuggingFace?
Yeah, of course. Just let me quickly show this. So if you were to use the API itself, it would return you this stuff. If you were to use on Azure, it would also return this stuff. It returns positive and negative and with associated probabilities. So I'm going to stop sharing. Couple of questions. Cool. I love it. You can use them offline. Yeah, you can just pull the models and the data sets you want to use. If you have them on your local, you will be able to do that. Just use them out of the box, like install the libraries, have the models, and you can just work it offline.
Gotcha. One more. What is the line of thinking to decide what model to pick inside HuggingFaces among all the ones available to train your use case?
For me, firstly, you need to pick the task. Like you can just filter on Hugging Face Hub. You need to pick the task. You need to pick the language that is, because like not every model is for every works for every task at once. Maybe except for ChatGPT and other
They can do everything.
generative models. For the framework, it's your own choice. You can just use TensorFlow. Like these models are available often in both in TensorFlow and PyTorch for you to use. So you can just use any framework that you wish. And I would say I don't know. Like I just if I'm going to accomplish a task, like for instance, my use case was predicting people's addresses, I just try multiple Turkish birth models and just fine tune and do experiments. And at the end of the day, I log them and see which one is the best.
Very nice. And we'll end it with this lovely comment. Thanks for the session, and Hugging Face documentation and training are very good too. So send that good feedback to the team at Hugging Face, doing great work on training everyone. So Merve, this has been great. I think we learned a lot. Again, a lot of beginners, but you've sent links. I have sent all the links as well, so you know where to find Merve. Always super helpful in the community. So I'm sure if you have any more questions, you can find her and she'll definitely answer them. But thank you for joining us, and thank you, audience, as well, for joining the stream.
Thank you so much. See ya.
Bye.